So for 1.5, we're going to be looking at some angle relationships here. Little chunk of vocab, so really important that you know the vocab from these sections, because it'll just these things will come up in future chapters all throughout the year. So really important that you hang on to the vocab that we're going to take a look at. So first things first, we're going to look at adjacent angles and we're going to look at vertical angles. So adjacent angles are ones that share a common side. So if you would look at, let's just say this angle and this angle, right? Those two angles are adjacent angles because they share a common side. So this ray, FG, belongs to this angle as well as this one. So that makes these two angles adjacent to each other or next to each other, right? But they have to share a common side. If two adjacent angles form a line, so if you look at that same pair of adjacent angles, right, these guys, when you put them together, they form this line right here. So anytime two adjacent angles form a line, we call them a linear pair. So just think of it, a pair of angles that form a line, right? Those guys are a linear pair. So together, they add up to 180 degrees. So they form that line right there. The other big one is vertical angles. Vertical angles are angles that are across from each other. So if you were to look at this one and this one, those guys would be vertical angles. So this angle and this angle are vertical. You could go this way with it. This angle and this angle are vertical angles. So vertical angles, one thing you want to know about them is they are equal to each other. So vertical angles are always congruent to each other. All right, so the measure of this angle must be the same as the measure of this angle. So those are just some of the main vocabs we're going to be talking about here. So as far as vertical angles go and those types of things, this is a great little list of vocab for you of kind of what you need to take away from this page. One of the things that we talked about up here, two angles that form that line add up to 180. Anytime you have two angles that add to 180 degrees have a special name to them. We call them supplementary angles. So again, these guys are anything that add to 180 degrees. And these could be any two angles, right? They don't have to be linear pairs. Linear pairs are always attached to each other to form a line, right? But if you have any two angles, whether they're attached or not attached, if they add to 180, then we call them supplementary. So anything that adds to 180 is supplementary. Anything that adds to 90 is complementary. Right, so good little list of vocab we got going on here. So let's try a few of these things. And again, you're always welcome to pause and work ahead of me if you would like to see how you're doing. So name an angle or angle pair that satisfies each condition. So let's find two adjacent angles. So again, any two angles that share a common side. There's a lot in here, so you could. I'm just going to pick two just to pick two, but there are several different that you could mention. What if we said angle LTN? So LTN. So this angle would be adjacent to NTE. Oops, forgot my angle symbol. Let's do this. Angle NTE. So that was just one example of adjacent angles, right? They share this ray as their common side. So that makes these two angles adjacent angles. Two acute vertical angles. So we're putting two ideas together on this one. So vertical angles, like we talked about up above, are any two angles that are across from each other and are equal to each other, right? So if you looked at these would act as vertical angles, so that would work. However, are these acute vertical angles, right? Well, if they measure 110 degrees, that's not less than 90, so they are not acute. So if we need two acute vertical angles, let's take a look at this one, and what would be vertical to that? We would have to look at this whole angle right there. So those would be vertical angles. So if you see this line that passes right through both, and you also see this line that passes through both, right? That's what forms those vertical angles. Another way to kind of look at that because sometimes students will say, well, why not use this one and this one, right? Well, they have to use the same set of lines in order to be vertical. So when I look at LS, that's a part of both angles, and when I look at RE, that's also a part of both angles that I marked. Okay, and so it's really important that the ones that we choose must share both lines that go through. Basically, they need to form an X. It's kind of the simple way to say it. So we could say angle RTS as well as angle LTE. And they didn't tell us the measure of those, but we could actually figure them out. So if you look right here, this is a line, right? Well, lines we already know are 180 degrees. And so this part of the line is 110. So what would that leave you with for this one right here, right? So this must be the other 70 degrees. So we could actually figure out more information on this if we think about it. They just weren't asking for that yet. Two supplementary adjacent angles. So if you look at the ones I just wrote on, see how these guys are adjacent to each other because they share this common ray. They're also supplementary because they add to 180 since they're a linear pair. So we could say angle RTS along with angle RTL would fit that description. And let's peek it down here at these last couple guys, and then we'll turn the page. Again, especially now that you've seen those, I would encourage you guys to pause and give this one a try as well. So two obtuse vertical angles. So this diagram's a little more complicated, but we could still find what we need to find here. So one pair of obtuse vertical angles that I'm seeing would be this one and this one. So I would say that those guys are greater than 90 degrees. That's what makes them obtuse. They're also directly across from each other, so they're vertical angles, sorry. So again, vertical angles, in order to be vertical, have to share common lines. So you'll notice this line right here, ST, is one side of both of those angles, and then RU is the other side of both of those angles. So they do share those common lines. That's what makes them vertical. So let's call it angles RNT and angle SNU. That would work. And there are others. That's just one example. Identify an angle that is supplementary to TNU. So remember, supplementary means they have to add to 180. So angle TNU, TNU. So what angle would be supplementary to that one where I just put the dot? Remember, supplementary means they got to add to 180. So in this case, we're basically looking for a linear pair, right? Let's pick an angle that's right next to it, like this one, that are for sure 180 degrees because they form a line. So when we put this angle and this angle next to each other, they form this line right here. And so I know for sure they add to 180, which makes them supplementary. So which one is supplementary to this angle? It would have to be this one. So let's say angle SNU is supplementary. Man, that's an ugly U. All right. Let's jump over to these guys. So let's put all those angle relationships together, do a little algebra with them. One thing they're also throwing in on this, and this was something you guys definitely would have learned in pre-algebra as well as algebra, is the idea of perpendicular lines. So remember, perpendicular lines are ones that form like a perfect T, right? They form right angles. So this is 90, this is 90, 90, 90, right? So these lines are perpendicular to each other because they form right angles. This is our symbol for perpendicular, if you're not familiar with that one. So we would read this as line AC is perpendicular to line BD. All right, that's what we got going on there. So here's one example that they've already done for you. In all of these, the goal is, how do I set up an equation in order for me to solve? So we have to look at what information are they giving us. So if you look at this diagram on the right, you'll notice that this is a right angle. So that means this line was perpendicular to this line. So they form this right angle. Well, what do we know about the measure of a right angle? We know it's 90 degrees, right? Which means this angle and this angle must total 90 degrees. Since when we put them together, they form this right angle. Key vocab word that we saw on the last page. Anytime you have two angles that add to 90 are called complementary angles. So that's another one of those vocab words that you want to hang on to. So here's the setup then. I know that this angle plus this angle must equal 90 degrees, and all of that is based on this one little mark that I see right here, right? That's what's telling me that they're 90 degrees. So once you set those up, real simple algebra, we just go through and we solve for x, and that's it. So this one just said find x, so we can stop right there. Right? Didn't ask anything further. So that's going to be the goal on these guys is, let's see if we can't, one way or another, set up an equation that would help us solve. So for this one, it's just saying find the values of x and y. They do tell us that these lines are perpendicular, so that's really important. They also marked it on the diagram for us. Okay, and so that's already there for us. So let's see if we can come up with x and y just based on that information. So if you look at the 5x and the x, real similar to what we just did up above, what do we know about their relationship? Well, since these lines are perpendicular, that means we got 4 right angles going on here. Right? They only have to mark one of them, and that automatically implies that the other 3 are also 90 degrees. Which means the 5x and the x must total 90 degrees. So 5x plus 1x must equal 90 degrees. And so that would be the equation that we're allowed to set up. And if we simplify that, we can solve for x. So 5x plus 1x we know is 6x equals 90. And just going to divide both sides by 6. And I believe it's 15. I'm going to double check that. Yeah, 15. So x is 15. Now let's go on to solve for y. And there's actually a couple different ways you could do this. But the easiest way, I think, is if you just look at this expression, 9y plus 18. Well, what do we know about the angle where this is sitting? Right? What we just talked about is this has to be a 90-degree angle, since that's a 90-degree angle. So we know that 9y plus 18 must equal 90. Right? It must equal 90 degrees. So if we go on to solve, subtract your 18, divide by 9, and we figure out that y is 8. All right. So now let's see if we can figure out, we're going to use that information to see if we can figure out the measure of angle MSN. So MSN, right here, MSN. Well, we don't even have to do any work on that one. Automatically, based on this information, we know that MSN is 90 degrees. They made that one way too easy for us. All right, so EBF, measure of angle EBF is 3x plus 10 degrees. DBE is x. We got perpendicular lines. So here's a diagram where, or a problem where they didn't fill all that into the diagram, so certainly we should do that. It's always helpful to look at a diagram and have all the information in the diagram. So you should always do that, especially on tests. So get in the habit of doing that on your homework. EBF is 3x plus 10. So EBF, so this guy is 3x plus 10. We know that DBE is x, so DBE is x. The perpendicular lines, so BD and BF. BD and BF, so that means right here is my 90 degrees, since those lines are perpendicular to each other. Now, what's the equation that we could set up in order to solve for x? based on that information that we just went through, we can see that this angle and this angle form this right angle, right, when you put them together, which must mean that the x plus 3x plus 10 must total 90. And then we can go ahead and solve that equation. So those guys are going to come together to make 4x. I'm going to subtract my 10 from both sides. And then if we divide by 4, we get x is 20. And that's all they were asking for, so we can move on to the last one here. And you guys should already know this one. Let me mention this really quick while I'm looking at it, because I know we're going to get problems like this, even though I'm not seeing it in our notes. Don't forget that this whole thing adds to 180 degrees, right? So they can also give you information here and here, and the equation that we might write is this plus this plus this plus this equals 180. And so that's going to be a common scenario that we'll run into as well. Last one, find the value of x as well as the measure of this angle and this angle. So they want 3 things from us on this one. So just looking at over here, hopefully you're recognizing what the setup would be now for this guy. I know that 3x plus 8x plus 2 would have to total 90 degrees. And don't forget our special vocab word for that. Anytime you have 2 angles that add to 90 are called complementary angles. So this plus this equals 90. So 3x plus 8x plus 2 equals 90. And then we go through to solve for x. So 11x, when I combine like terms, subtract 2 from both sides. So x is 8. So that's the first part. Just be careful, especially on a test. If you are asked for something more, don't forget that. It is really a common issue in here. That's why you hear me keep saying it in these lessons. So if x is 8, what does that make this? So 3 times 8 would be 24. 8 times 8 plus 2, so 64 plus 2. And sure enough, you can check to make sure that we did that right. Those do add to 90, so I know my answer for x is correct. And we now have all the information they were asking for. So that's the end of that.